Hello, welcome to a new video from Maatwielen, my wheel building company in the Netherlands. In this video I would like to show you a project I've just finished, during which I had to solve some interesting problems. So I thought you might like to know what these problems were and how I solved them. If you like the video, please like it and/or subscribe to my channel. Some time ago, one of my customers asked me to look at the repair options for his Mavic Cosmic Pro Carbon SL rear wheel. Here you see me holding this wheel. What had happened? The customer had mounted a tubeless tire on this wheel and was increasing the tire pressure when suddenly air from the tire escaped to this part here, where it doesn't belong, and which can't stand much air pressure. Consequently, the rim was ripped open and was damaged beyond repair. Now, the first obvious repair option was replacing the rim by a Mavic rim, of the same type. So I checked the price and delivery time and informed the customer. In the meantime, I considered if there was any other option, and I decided that there was. Wheels from brands like Mavic, Campagnolo or Fulcrum tend to use non-standard components. For example, spokes or nipples of non-standard shapes and sizes, often requiring special tools. Or they have a non-standard number of spokes, such as 21. This means that the repair options are very limited, if there are any at all. Now, this Mavic Cosmic Pro Carbon SL wheel, however, was different in that it was built from standard components, except for the spokes. This meant that I could use any other rim with 24 holes. Now, what about the spokes? The Mavic spokes were not standard, but rather near standard, so to speak, as they differed only slightly from standard spokes. They were wider and thinner than standard spokes, and their heads had a slightly larger diameter than those of standard spokes. So the question was whether I could use standard spokes to repair this Mavic wheel. If the answer was yes, it would mean that I could use any 24-hole rim. If the answer was no, the only option would be to replace the rim by a new Mavic rim or by another 24-hole rim with the same height as the original Mavic rim, because then I could reuse the original spokes. In the end, the customer decided that he wanted having both the front and rear rim replaced by a 45mm high full carbon rim, if this was possible. So now all depended on whether standard spokes could be used. There were three questions I asked myself. 1. Does the customer accept the cosmetic difference between the wider Mavic spokes and the less wide standard spokes? To allow the customer to appreciate the difference between the original spokes and standard spokes, I replaced 2 Mavic spokes by 2 standard spokes. Here you can see the difference. The customer had no problems with the standard spokes in terms of what the repair wheel would look like. So the answer to the first question was yes. Actually, this also gave me a good indication of the spoke tension I needed to use by comparing the tension of the Mavic spokes with that of the standard spokes. Now, the second question I asked myself was, how do standard spokes compare to Mavic spokes in terms of spoke mass, so to speak? Do I lose spoke mass, that is, the amount of spoke material, if I use standard spokes? In other words, Would using standard spokes make the wheel less stiff or less strong? This question was easy enough to answer. I simply compared the weight of the Mavic spokes with that of the standard spokes I intended to use, Sapim CX Sprint, and found that they almost weighed the same. So this meant there would be hardly any loss of spoke mass. This fact, combined with the fact that the replacement rim would be higher and therefore stronger, convinced me that the repaired wheel would be at least as strong as the original wheel and most probably stronger. The last question I asked myself was, does the smaller head diameter of the standard spokes provide enough support in the hubs? The difference in head diameter turned out to be 0.3 millimeters, and I decided that this small difference wouldn't be a problem, but that using a tiny spoke head washer would be ideal. So I decided to use these Sapim spoke head washers, which increased the diameter to 4.8 millimeters, which was too large for the hub, so I had to reduce the diameter with a Dremel tool to make it fit into the hub. Here you can see me reducing the diameter. Warning: wear protective glasses as the tiny metal fragments can cause quite severe eye irritation. So now I was ready to rebuild the wheels with new rims. Here I'm taking the old Mavic wheel apart. I made a tiny marking on the hub to make sure that the spokes in the new wheel would be at the same places relative to the valve hole. So here you can see I've already installed the new rim, and I'm checking if the spoke at the marking is at the right place, that is next to the valve hole. Here I'm checking if the diameter of the Sapim washers is small enough. Here I'm building the non-body side of the rear wheel, and as you will see, the washers have a really tight fit, but that's alright. The diameter should not be smaller than necessary. The larger the diameter of the washer, the more the support for the spoke head. And here I'm building the front wheel, where I also used the Sapim washers. Here a close-up of the rear hub with the washers in place, providing support to the spoke head. I end this video with some pictures of the end result.